Okay, boys, morning, all of you. In the last period, we were discussing, that is, in case of topic polymers, classification of polymers. So, we have discussed classification of polymers based on their sources, that is, natural polymers, semi-synthetic polymers, synthetic polymers. Next, based on their structure, linear polymers, branched polymers, cross-linked or network polymers. Next, based on their polymerization process, that is condensation, addition and ring opening polymerization. Is it clear? Okay. Next again we have discussed based on their molecular forces. Based on their molecular forces, that is elastomers, fibers, thermoplastic polymers, thermosetting polymers. तर इथपर्यंत आपण लास्ट पिरियडला पाहिलेलं आहे क्लासिफिकेशन ऑफ पॉलिमर्स. आता याच्यामध्ये नेक्स्ट आहे का क्लासिफिकेशन ऑफ पॉलिमर्स बेस्ड ऑन टाइप ऑफ मोनोमर्स. बेस्ड ऑन टाइप ऑफ मोनोमर्स हियर that is it is classified into two types. One it is homopolymers and another it is copolymer. Here that is based on type of monomer. Here now homopolymer, that is here the polymer is formed by using only one kind of monomer. एकाच प्रकारचा मोनोमर घेऊन जर त्याच्यापासून पॉलिमर फॉर्म होत असेल तर त्यावेळेस त्याला आपण काय म्हणतो, homopolymer. Homo means same here. So by using only one type of monomer here, the polymer is formed, then it is known as homopolymer here. For example, polythene, that we have already seen. Polythene here, it is example of homopolymer here. For example, polythene, or for example PVC, polyvinyl chloride here, or for example Teflon, it is also homopolymer, Teflon here, or for example polyacrylonitrile, or for example polypropylene. So all these polymers, they are homopolymers, that is they are made up of from only one kind of monomers, and so therefore they are known as the homopolymers here. Another type copolymer, or it is also known as the heteropolymer. Copolymer, or it is also known as the heteropolymer. Hetero means different. So here, if more than one kind of monomer is used for the preparation of polymer, then the polymer form it is called copolymer or heteropolymer. म्हणजे एक पेक्षा जास्त वेगळ्या टाईपचे जर आपण मोनोमर घेतले आणि त्याच्यापासून जर पॉलिमर तयार झालं तर त्यावेळेस त्याला आपण काय म्हणतो, कोपॉलिमर हियर. So for example, consider here this, that is example here it is, for example terylene. Terylene here, terylene or polyester, त्याला आपण काय म्हणतो, पॉलिस्टर म्हणतो. aniline. For example, Bunayas, or for example, Bunayan, etc. Here, styrene butadiene here, Bunayas, or Bunayan, acrylonitrile and butadiene, monomer used here. So if different monomers are used for the preparation of polymer, then it is known as the heteropolymer, or it is also known as the copolymer. So it is very important, you must know the monomer used for the preparation of polymer here, because question is asked here, that is the which of the following is copolymer, or which of the following is homopolymer for MCQ. So that you have to prepare. So this is about the classification of polymers here based on type of monomer here, that is homopolymer, copolymer. Okay. Now again there is another type here. Classification type, there is another, that is classification of polymers based on biodegradability, that is based on degradability. Now as you know this, that is polymers here, that is there are two types here. Depending on their biodegradability, there are two types. One it is, that is biodegradable polymers. One it is biodegradable polymers, and another it is non biodegradable polymers. So based on their biodegradability, polymers are mainly classified into two types, that is biodegradable polymers and non-biodegradable polymers. Now the meaning it is in the name biodegradable, that is the polymers which undergo degradation. Polymers which undergo degradation under the environmental forces here. Environmental forces, that is temperature, pressure, rain. So under the effects of such forces, if the polymers they undergo degradation here, then they are said to be biodegradable polymers here. And another type, non-biodegradable polymers, that is the polymers which does not undergo degradation under the effect of environmental factors here. They are known as the non-biodegradable polymers. That means here, that is in case of biodegradable polymers, that is we can take here example, that is for example PHBV, polyhydroxybutyrate को beta hydroxyvalerate here, or for example another nylon 2 dash nylon does not undergo degradation here. So it is polyethylene here, or for example polypropylene, or for example PVC here, etc. So these polymers, they does not undergo degradation here under the effect of environmental factors, and so therefore they are known as the non-biodegradable polymers. Is it clear? So here that is, on the basis of their biodegradability, here are two types, that is biodegradable polymers and non-biodegradable polymers. Question is asked here, what are biodegradable polymers? Simple definition: the polymers which undergo degradation under the effect of environmental factors are called biodegradable polymers. Or what are non-biodegradable polymers here? That is the polymers which does not undergo degradation under environmental effects. They are known as the non-biodegradable polymers. Or for MCQ question is asked here, which of the following is biodegradable polymer? Here, which of the following is biodegradable polymer? So again you have to keep in mind this, and you have to prepare different examples again. So in this way here we have discussed classification of polymers, different classification types. Now here we'll start with next part. Here, prepare thoroughly these classifications. Here their definitions are important. You have to prepare definitions. Again you have to prepare examples in case of classifications. Now next, now we'll discuss here, that is rubber. Next part, now here rubber, it is again a polymer here. That is, as we know, all those substances which shows elastic properties, generally those which shows elastic properties, they are made up of from rubber. For example, rubber bands here, or for example balloons, or for example tires of motors, or for example tubes present in the, that is, tire, or for example hand gloves here. So all these are nothing but these are obtained from rubber here, and so therefore again here this rubber, it is a polymer here. Now in case of rubber, the monomeric unit present in rubber, it is, that is isoprene units, that is the monomer present in rubber here. I will show you structure, isoprene unit. 2-methyl-1,3-butadiene, or it is also known as the isoprene here. So this is the monomeric unit present in rubber here. Now here, that is how the formation of rubber takes place here. Same, that is polymerization process here. That means, for example, if we carry polymerization of this rubber, that is this isoprene unit, for example, consider, I will show directly here, this, consider this will carry its polymerization process here. So what happens? Polymerization process, again we have to take care that is N times. We have to take this N times. So what happens? These isoprene units, they will undergo polymerization, addition type of polymerization. That is the addition of this monomeric unit takes place. And formation of here this polyisoprene takes place. Formation of here polyisoprene. That means what happens here? That is here double bond, it is converted to single bond, and here there is formation of double bond takes place. Yes. And so here this again, that is, and we have to show here this N times. So this formation of this polyisoprene unit takes place. Polyisoprene or rubber. So in this way here this formation of rubber takes place. That is, these isoprene units, they undergo polymerization. They undergo polymerization and forms these polyisoprene units here. That is the formation of rubber. So the monomeric unit of rubber, it is isoprene. Now the natural rubber structure, generally it is found in cis configuration form. I will show again here the structure here. That is, for example, consider here this. That is here there is presence of double bond here. Here. Now this is polymeric unit. So we have to show it is polymer. So which indicates polymer, that is instead of N times, you can also show in this way. That is, this unit is continue in this direction, it is continue in this direction and in this direction. Here. So this is, that is the structure of natural rubber here. Now in case of rubber, that is, there is, it also will say cis polyisoprene unit. That is, there is a cis configuration across this double bond here. And these rubbers, natural rubber, they are having weak van der Waals force of attraction. Weak van der Waals force of attraction is present in it, and they are having coil structure. Coil structure and as like spring here. That is, spring, it is having elasticity. So similarly, this rubber, it is also having, that is, elasticity with coil structure and presence of weak van der Waals force here. Now here, that is actually the rubber obtained from rubber plant here. That is the rubber obtained from rubber plant. It does not show all these properties of rubber here. Raw rubber. It does not show all the properties of rubber, that is elasticity or toughness, high tensile strength. So here that is to form perfect rubber with high elasticity, high toughness, here high tensile strength. What it is done here? That is the vulcanization of rubber is carried. Vulcanization of rubber here, that process is carried, and so now next part here, that is we are going to discuss vulcanization of rubber. So that part we'll discuss, we'll continue